All right, so you guys have your periodic table in front of you. Here's my sketch. It's beautiful, I know. Here we go. Okay, there we go. So I just want to make sure we're identifying these groups correctly. So what is group 1 called? Or what are we thinking of? Alkali metals, right? Group 2, or alkaline earth metals, right? Alkaline means they're basic, so they have different characteristics. So we call this group 1A, group 2A. We skip the transition metals because they have varying characteristics that give them not really they don't have consistency like all the representative elements do. So group 1 is very similar to every element within. Group 2 has similar characteristics with every element within. Group 3A doesn't have a name, but it starts with who? Boron, and then aluminum, and then we have some like post-transition metals starting to occur in there, germanium, things like that. Group 4A starts with who? Carbon, which is in silicon, which is starting to get into the non-metal area. Group 5A, okay, starts with nitrogen. They actually have names, but we don't have to remember these couple of names here. Group 6A starts with who? Oxygen. Group 7A has a name. Halogens. And group 8A has a name. Noble gases. Good. All right, so let's quickly check through our scavenger hunt. And Riley, give me the first one. SI, right? Silicon. Good. Their name. Rainier. Next. CF, which is called what? California. Okay. Number 3. Ryan, Estes.
83.
83. And bismuth is my favorite, and I'll tell you why. Because it's gorgeous. And I have some. I'll pass around. I have some in a baggie, so don't open the baggie just because there's like little bitty pieces, and I have like one big chunk. So you can pass around bismuth. Who's ever heard of bismuth, like in real life? Where would it be found? Yeah.
Like rocks and stuff.
It isn't rocks, they're like bismuth ores. Anybody else? Maybe even said the word biz. Maybe your tummy didn't feel good. Pepto-Bismol has bismuth in it. You were eating this stuff, drinking it, coating your stomach with it to make your stomach feel better. So pass it around for me, and they'll make them up to the front here shortly. Ryan, give me 4. Which element does argon belong to? Which group?
Noble gases.
Noble gases, group 8, good. Number 5, Andrew?
CD.
So cadmium has a higher mass, good. Elizabeth, give me 6. 12.01 is the mass of carbon, very good. 7, Ryan? Which term? Sorry. But lanthanide series, good. So the one starts with an L, the lanthanides, which is on the bottom of the periodic table. Number 9, lowest atomic mass, CJ? Totally skipped 8. Can you also do 8? Gold, good. AU, gold. And then hydrogen is number 9. Ariane, how about 10? Which is first element greater than 100? RU, what's the name of that? Rutherfordium, which is named after scientist Rutherford. Everybody's got to have something named after him. Kern, what you got for 11? First, so this is the one I just mentioned this. You guys maybe didn't pick this up. So basic metals are the alkaline earth metals. So the first metal in group 2. Here's the first metal in group 2. So if you need to write down that basic metals mean alkaline earth metals, that's something for you to write down, okay? Go for it, Karen. 11. Good, beryllium, Be, beryllium. So alkaline means basic. All right, 12, true, false, Cole? False, good. You guys can see that, but they're not in the same group. Groups go up and down or side to side? Up and down, they're columns, good. Corbin, can you give me 13?
Francium.
Francium, Fr, is the hugest metal, okay? It's very, very large. 14, how many protons are in magnesium, Chandler? Not here, Jacob? 12, good, so you're looking at the atomic number. Number 15, which is a non-metal, Aiden? Silicon, very good. It's a metalloid. It has interesting properties. Do you guys know what in the real world is made of silicon? Yeah.
transistors and basically everything else we do work.
Yeah, like it's used extensively in computer science and building up the parts for Moore's law, right, to help with electrons traveling, but it's also used in solar cells. Okay. Wesley, give me, where are we at? 16. Tungsten, tungsten. Sometimes these don't work out, right? If I say potassium, you think P, but we know it's not P because P means phosphorus, right? What is potassium? K, right? We can always make mistakes, just have to think about it. 17, Bryce? Palladium?
Yeah.
Gotcha. PD is good. I know some of these symbols, the names are wonky. I will mispronounce a good 10 of them occasionally, okay? Astatine belongs to which group? Kendall? The halogens. We rarely ever use them, but that one in particular, but it is a halogen. Nana, number 19. Barium. Good BAs, barium. And everybody, this poor letter that's not used. J. I can't spell my name out in periodic symbols. There might be another one. Is there another one? Q, I think it used to be there. Where's Q? So they actually have named them now. So on the bottom, like 114 through 117, where it's like it's not up there anymore. It's named. Where are we in now? Okay, so they named them all. So yes, Q is starting to be phased out because we have names for the elements. It takes like probably 5 years for a name to get proposed and then passed. I have a friend who's on like the organic chemistry naming committee for IUPAC International Union of Pure and Applied Chemists, IUPAC, and he said it takes like 5 years, and I was like, that's a shame. Okay, so go to my website for me. Thank you. If you got to pass around the bismuth, we did not get to feel or see the bismuth. Looks like everybody got a chance. Okay, it's my favorite because it's beautiful. All right, go to my website and go under Unit 2, and in Unit 2 you've got under more, right? Remember, you always have to hit more to see every document that's here. Go down to where it says Honors Chem Atomic Model Note Student. That's going to be a PDF that pulls up. Give me a thumbs up when you have pulled up that PDF. It might take a second to load. It's a little bit of a large file because of all the images involved. So once you get there, help your friend out next door if they can't find out where they're going. It's going to look like this, right? Okay, so basically the evolution of the atomic model sets us up for success with understanding what happened in the past, what happened not too long ago, and then hopefully what's going to happen in the future, with really like expanding our understanding of what the atom is, what it can do, what it looks like on this nanoscopic level, which we actually have no idea. Like we have no machine which can actually visually see. Like a microscope cannot see what an atom looks like. But we have lots and lots and lots of tools that can give us little bitty indications of like, oh, there's a nucleus in the middle and it's pretty dense and there's positive protons in there. Oh, we put a laser on it and the laser active behaved this way, so now we think the electrons are out here. So there's tons of tools that have helped us get to where we are, but there's still more to be discovered about a lot of things. I'll borrow this from your class. So I want you guys to see the past, present, and the future of what we're looking at with the atom. So I have provided some guided notes to give you at least the minimum, especially some of the images. So find this for me. But please do not only take what's on here. So try to write down a couple of the extra things that you'll find on these notes. So you notice the very first person to propose anything about atoms was Democritus, way back. Okay, so Throwback Thursday, here we go. And then apparently it took us 2,000 years to really see what Democritus did in Dalton, which you read about in your reading last night. Dalton, he developed something which was called the atomic theory, right? Those were the 4 like bullet points you wrote down on question 1 of reading guide. So paraphrase some of this, put abbreviations, and I've already provided some abbreviations on here. But for example, the atomic theory, knock it down, like dumb it down to what you need to know. Okay, so I'm going to give you guys maybe half an hour to take your notes first, but let me tell you more. Okay, so before you start getting knee deep in here, so eyes up here. Okay, after you finish walking through this, go to my homework website, and this is, I told some of you guys we were starting a project today. I'll tell you more right now. So go to homework and go under homework for tonight. Give me a thumbs up when you're there. Okay, and click on the Atomic Model Choice Board project. What does it say next to it? With partner. So it's nice to know that you have the option to do either or. I already know that you need, some of you need to choose wisely. This is not like a, all right, man, I'm going to do half and you're going to do half. Okay, it's going to be a collaborative experience. So we'll talk about that more. But I want to let you know that when you click that, you have the option to select a number of activities that correlate with the atomic model or the atomic evolution of the atomic model. So I'm going to let you read this, but let me give you the gist of it. In terms of what I'm looking for, which most of the time I assign a project really early in the unit, it's not due for like 2 weeks. Okay, so it's usually due right before the test because it serves as a review before the test. Because this is all stuff we're talking about now, but we won't talk again for a good 2 weeks. So in terms of what you're going to demonstrate are how at least one scientist experiments led to discovery of one of the subatomic particles, how the modern model of the atom is, or what it is and how it relates to behavior of electrons, nature of science, basically how does science happen in everyday life, scientific theories, and then the never-ending search for like the true scientific like meaning to science in our world. So down below you see the choice board itself, and you can see you have many options. So 16 options I think with 4x4, but you must choose one that's titled knowledge. You with me? Okay. Knowledge, synthesis, application, and evaluation. And there's there's a lot of application, there's a lot of synthesis, there's only a couple of evaluations, so we'll have some people that choose the same, of course. Okay? We good? Yes or no? Yes. Okay, so let's go back to this at the end, but right now work on your notes, okay? If you need to spread out to get some elbow room, by all means, go to the lab stations. Just that back one, we're working on some lab stuff, so just don't sit back there. All right, so I'm putting 30-minute timer on so I know where we are in half an hour. You can listen to music. I'm listening to my music too. If your phone distracts you, I will take it from you. So don't let it be a distraction. The person next to you can be a fantastic resource on that.